Hello, hello. This video will be going over Edmentum Semester B for Algebra 1, multiplying polynomials. And this is going to be the tutorial going over that section. So let us dive straight into it. So our first page of note is going to be page 5, where it has a question that asks us, take a moment to review classifying polynomial expressions, then classify each polynomial based on its degree and number of terms. Drag the descriptions to the correct locations on the table. Each description can be used more than once. So before we get into it, let us explore what a degree is and how we could define polynomials using its number of terms. So naming a polynomial using its number of terms is actually easier. So let's start there. So when we have a expression that has one term, say we had 3y, this is just one term, so we call that a monomial. If we had an expression that had two terms, let's say we had 3y plus 3x, we would call this a binomial. If we had something that had uh, a if we had an expression that had three terms, let's say we had 3y plus 3x plus 4, this would be a trinomial. So they're all polynomials, but they have different prefixes, mono, bi, and tri, to signify how many terms are in each expression. So we could use that information to start answering our question. So our polynomial 5x has only one term, so that is going to be a monomial. 7 is just one term. Once again, it's going to be a monomial. X squared plus 4 has two terms. It's going to be a binomial. X squared minus 3x plus 11 is going to be three terms. Trinomial. 2x minus 9 is going to be binomial. So that completes the part as far as naming polynomials using number of terms. So now let's go ahead and explore what it means to name a polynomial using degrees. So just as a reminder, a degree of a polynomial is the degree of the polynomial is defined as the largest power uh, of a polynomial. So if we had, say, 5x to the second power minus 2x plus 3, our degree would be 2, because 2 is the biggest power of this polynomial. So this is of degree 2. If we had, say, 2x squared minus 5y plus 2z to the fifth, our degree would then be 5, because 5 is our largest power that we have within the polynomial. So we define, or that's the definition of degree. As far as naming a polynomial based on its degree, a degree 1 polynomial is going to be linear. This is your classic y equals mx plus b. You have one variable. Well, in this case, it's the base form. Let me give an actual example so it's slightly more clear. And I can't delete, so let's actually manually click that. So if we had the expression 3x plus 2. So we have our one variable and it has a degree of 1. And this is a linear equation. This is equation of a line. A degree 2 polynomial, generally speaking, say we had, let's just go with the most basic x squared. This is a quadratic. And its graph shape is going to look like a U. And D3, all right, actually, we don't have any D3, so we don't have to get that far. What about D0? What if we just have no variables with powers? Let's say we had 5. Well, if we remember our definitions from earlier in our algebra course, this is just a constant. So a number just by itself is a constant. So with that review in mind, let us see what our answers for each of these polynomials is going to be. So 5x has a power of 1, a degree of 1, so it's going to be linear. -7 is just a number, or in algebraic terms, a constant. X squared plus 4 is going to be a quadratic. X squared minus 3x plus 11 is going to be a quadratic. And 2x minus 9 is going to be a linear equation. And that is the end of page 5. So the next page I want to skip to is actually going to be page 9. I very much encourage you to read through and go over the other pages, but here is where I want to start off explaining what the distributive property is, and that's what we're going to be going over on this page. Or that's what we went over on the last page, and here we're going to get more into the meat of it. So, as a reminder, the distributive property means that when we have a situation where we have a number next to a parentheses, let's say we had 4 times 3 plus 2, whenever we have a number next to parentheses, the way that we resolve this is by multiplying this outside number to each term inside the parentheses. So 4 times parentheses 3 plus 2 would be 4 times 3 is 12 plus 2 times 4 is 8, which would be 20. And we could double check this by seeing that 3 plus 2 is 5. So 4 times 5 is just 20. So what so that's a very basic version of the distributed property. More often than not, the way that you're going to use the distributed property is with polynomials. That is to say, if I have something like 3 parentheses 2x minus 1, I can't resolve what's inside the parentheses. I cannot simplify that. So the way that I progress and the way I simplify this is by taking this 3 and distributing it to everything inside the parentheses. So should have covered this on the last point, but I just want to reiterate and remind everybody that whenever you have a number next to a parentheses, the implied operation is multiplication. So this is 3 times 2x minus 1. So when we have 3 parentheses 2x minus 1, the way that we resolve this, the way that we simplify, is by distributing the 3 to everything on the inside. So 3 times 2x is going to be 6x, and 3 times negative 1 is negative 3. So that's how you would distribute and solve here. If I had a variable and I had, let's say 3x minus 2y plus 4, I would do the same thing. I would multiply this x, this outside number or variable, to every term inside the parentheses. That's what it means to distribute, to use the distributive property. So 3 times 3x would be 3x squared minus 2y times x would be 2xy plus 4 times x would be 4x. So that's how you would simplify here. Now, if we look at our example, we are given both a number and a variable. But the principle is the same. We just take whatever's on the outside and we multiply it by every term on the inside. So let's take a look at what that would be. So 3x times 2x squared would be 6. 3 times 2 is 6. And then x times x squared is going to be x to the third. 3x minus times 4x is going to be 12x squared. And 3x times 9 is going to be 27x. And this is your answer. This is how you distribute and simplify an expression like this. So if I delete this, our answer, or this page should take you through the answer, and we should get the same thing. So let's go ahead and verify that. That, yes, we take 3x and we distribute to all the pieces inside. And ultimately, we get 6x to the third minus 12x squared plus 27x. So that's how we do the distributive property, and that's how we use it to simplify expressions. And on page 10, we have a question asking us to use the distributive property. So we are going to multiply 5x squared, or negative 5x squared, times 6x minus 1. So let's go ahead and try and do that. So we're going to take negative 5x squared, and we're going to multiply it by 6x. So let's just isolate that part. We have negative 5x squared times 6x. So we could only multiply numbers with numbers and variables with the same kind of variable. So we could break this up into negative 5 times 6, which would get us negative 30, and x squared times x, which would give us x to the third. So that becomes our first term. So now we take negative 5x squared and multiply it by 1, or negative 1 rather. So negative times a negative would be a positive, so that would just be 5x squared. And that would be our answer. We just combine them both. So that's going to be negative 30 x to the third plus, because the negative canceled, turns into positive, 5x squared. And that would be your answer. Next, I'm actually going to skip ahead to page 14 and jump right into the question, how do we simplify parentheses x squared minus 5 times parentheses 2x minus 1? So there's a whole method to showing how to do this, and I will explain that in a moment. But I do want to just jump into this problem and show how related this is to the distributive property. So we take, let me just rewrite it over here. We have x squared minus 5 and 2x minus 1. So what we do is very similar to what we did before. We take the first parentheses and we look at each term and we multiply that term into everything in the second parentheses, and we're going to do the thing with the second term and multiply that into the second parentheses. So we're going to distribute each part of this first binomial into our second binomial. So let's take a look first at our first term being multiplied into the second binomial. So this becomes 2x to the third, because x squared times 2x is 2x to the third, minus, that becomes x squared times -1, that would be negative x squared. And now we've multiplied our first term into everything in the second binomial. So now we're going to do the same thing with our first term, or our second term, excuse me. So -5 times 2x is going to be negative 10x, and -5 times -1 is going to be plus 5. And I do believe nothing else could be combined or simplified, so that would be 2x to the third minus 2x. It's going to be minus 10, so it's going to be this one or this one. So 2x third minus 2x squared, and it's going to be plus 5, so it is going to be C for me. Very well may be shuffled around for you, so make sure we choose the correct answer. So I showed you the direct way and the direct connection between the distributive property and multiplying two binomials. And that logic actually follows through for any uh, numbered term polynomials. You multiplying all the terms of one polynomial by all the terms of another polynomial when you're multiplying two polynomials. But very specifically, for multiplying two binomials, they also have the FOIL method for teaching you how to do this. FOIL standing for first terms, outer terms, inner terms, and last terms. So to break down the example given, we have x plus 3 times x minus 5. Using the FOIL method, we multiply our first terms in each binomial. So x times x, which is going to be x squared. Then we are going to multiply our outside terms, that being our x and our 5, or our -5, because they're the outside terms of our binomials. So that would be -5x. Then we multiply our inner terms, the two terms, the two terms that are on the inner part of the binomial multiplication. So that would be 3x plus 3x. And then we multiply our last terms in each binomial. So that being 3 and -5, so -15, which you could then simplify and add. So that'd be x squared minus 2x minus 15. So that is the FOIL method. It's not different than what I showed you before. If you look back and look at your notes, we did the same thing. This is just very specific for binomial, multiplying two binomials, and it will be referenced in a lot of your work to come in algebra. For instance, it specifically asks you to multiply these binomials using the FOIL method on page 13. It's just an example, but there will be questions like this where it tells you to use the FOIL method. You should know the FOIL method, but just understand what they're telling you and what the connection is between the distributive property and just multiplying polynomials in general. So let's take our 2x plus 3, multiply that by our 4x minus 5. So our first terms are going to be 2x and 4x, giving us 8x squared. Our outside terms are going to be 2x and negative 5. So that's going to be minus 10x. Our inside terms are going to be 3 and 4x. So that's going to be plus 12x. And then our last terms are going to be 3 and negative 5, that being negative 15. So we multiplied all these terms together, we FOILed them, and ultimately we get, that should be 8x squared. I think I wrote that. I might have deleted that, but that should be an x squared. So this is 8x squared plus 2x minus 15, and that is your answer. And if we delete this and go through it, it is indeed our answer. Next, we're going to take a look at page 15, where we have a question where it tells us to simplify the polynomial expressions by combining like terms, then multiply the resulting binomial expression to find their product. So we are going to do just that. So let's look at our first polynomial. And it looks like we do have some like terms. I see an x term here and an x term here. So we can combine like terms. So let's do 6x minus 2x. That is going to be 4x. And then the 9 can't combine with anything else. So that's going to be minus 9. And here, there's only one x term. However, there are two constants or two numbers. So I'm going to lead with my 5x, but I'm going to combine 8 minus 5, which would be plus 3. So I have now combined like terms, and now we're going to multiply the two binomials. So let me go ahead and set that up over here. That's going to be 4x minus 9, 5x plus 3. And we're going to take our first term and we're going to multiply it by everything in our second binomial. So that is going to be 4x times 5x, which would give us 20x squared. And then 4x times 3, which would equal to 12x. From there, I'm going to multiply my second term by everything inside the other parentheses. So that's going to be negative 9 times 5x, which will give us negative 45x, and negative 9 times 3, which would be negative 27. And the only like terms I can combine here, it seems, are 12x and negative 45x. So this becomes 20x squared. And what is 45 minus 12? So that would be 3. 4 minus be 3. So that would be negative 33x minus 27. So I do believe this is our answer. So let's go ahead and input that. So that is going to be 20x squared minus 33x minus 27. And we should be good to go. Perfection. Next, we're going to take a look at question 18, page 18, and we are hit with another question. On pages 16 and 17, it goes over another method to solve multiplying two polynomials. If that method speaks to you, I encourage you to explore that, but I'm going to go with the universal method. This is going to work with any polynomials that you guys are multiplying. So let me go ahead and take a look. Okay, so we are going to be multiplying polynomials again. So I'm going to take my first term and multiply it by everything in our second polynomial, and then see what we get. 4 times x should be 4x to the third. X times 5x should be 5x squared. X times 6 should be plus 6x. And that's everything in this polynomial multiplied by x. Secondly, I'm going to take my second term, my 9, and multiply it by everything in this polynomial. So that's going to be 9 times 4x squared. That's going to be plus 36x squared. 9 times 5x is going to be plus 45x. And finally, 9 times 6, which is going to be plus 54. Next, I'm going to see if I could combine like terms. I don't see any other x to the third term, so that's going to stay 4x to the third. I'm going to cross that out, make sure that I know that I use that. And I do see 2x squared terms, so I'm going to add those together. So that's going to be, well, let's just put them together for now. So let's group them. 5x squared plus 36x squared. Dealt with those. Next, I'm going to see I have two x terms. Put those together. So I'm going to plus 6x plus 45x plus 54. And then I'm going to add my like terms. So again, 4x to the third is by itself. It has no other like terms. 5x squared plus 36x squared is going to be plus 41x squared. 6x plus 40 should have been 45x. Missed that. So that's going to be plus 51x plus 54 should be our answer. So let me go ahead and write that down. And let's see if that is what we need for our adventum. So that's going to be 4x to the third power. That's going to be plus 41x squared. That's going to be plus 51x plus 54. All right, fingers crossed. There we go. Moving on. Next, we are going to take a look at page 20. So page 20 gives us another question. And although it looks more complicated, the numbers and terms we're working with are getting more complex, we are not going to worry because we're just going to follow the same steps and we're going to get our answer. So let's go ahead and see. The answer already gives us the form of what the answer is going to look like. We're going to have an x to the fourth term, x to the third term, x squared, x term, and a constant. So thank goodness for that. So let's go ahead and set this up, multiply our first term into our polynomial, that being 4x squared times 6x squared. That should be 24x to the fourth. 24x to the fourth. 4x squared times 8x is going to be 32x to the third. And 4x squared times 5 is going to be plus 20x squared. Next, I'm going to take my second term, do the same thing, multiply it into our second polynomial. 2 times 6x squared is going to be 12x squared. 2 times 8x is going to be 16x. And then 2 times 5 is just going to be our 10. I'm guessing that this is going to be our constant here, but let's see. So we only have one x fourth term, so 24x to the fourth. Took care of that. I only see one x to the third term, so likewise, we're going to put it down here. 32x to the third. I see two x squared terms, so I'm just going to do 2 steps in one and add them together now. So 20x squared plus 12x squared is going to be 32x squared plus 16x plus 10. And that should be our answer. Let's see if this works. So that's going to be 4. Oh, no, that's from the old problem. That's going to be 24, 32, 32, 16, and finally 10. All right, we're on a roll. And finally, we are going to do page 25, which hits us with another question. This is telling us to simplify the following expression. So it's not just a simple multiply two polynomials or two binomials, it's simplify the entire expression. So this is not a direct question that is just multiplying the binomials, but it's a question that involves multiplying these binomials. So we're going to apply it to a broader question. When you're given something like this, it may look intimidating, and you may be asking yourself, well, where do I start? How do I start this? Well, we're going to fall back on what we know. And what we know is that math follows an order of operations. And many of you may remember that there is a acronym, acronym, to help us remember what the order of operations is. It is PEMDAS, which tells us how we are supposed to do this uh, to simplify this expression. So the first thing we're supposed to take care of is anything inside the parentheses. Parentheses. I'm confident I spelled that wrong. I am a terrible speller. Parentheses. Let me see. That was close. But the order of operations starts with parentheses, so let's take a look at each of our parentheses. Is there anything that we can simplify inside of each of our parentheses? And at a glance, it doesn't look like it. There are no like terms. You cannot combine an x squared term with an x term. So there's nothing to resolve as far as parentheses. Next is exponents. And although we do have exponents here and here, once again, there's nothing to really solve there or simplify there. X squared, until we know what that x is equal to, is just going to remain an x squared. So we're good with parentheses. We're good with multiplication, or we're good with exponents. Next, we have multiplication division. And here, we could actually start to do something because, okay, there's nothing that we could simplify here using multiplication division. Nothing here we could simplify using multiplication division. But here, that is two binomials being multiplied by one another. So here's where we're going to apply our lessons, what we've learned in this section. So I'm going to do some side work over here. And that's going to be x plus 5 times x minus 7. I'm going to take that x, that's going to be x times x is x squared. X times negative 7 is going to be negative 7x. 5 times x is plus 5x. And 5 minus or times negative 7 is going to be negative 35. If that went too quick for you and you're not sure how I got this, I very much encourage you to go back and rewatch parts of these videos until you understand how I got there. That being said, times 30 or minus 35, I have two like terms, so this is going to turn to x squared minus 7x, or excuse me, that's going to turn to x squared minus 2x, because negative 7x plus 5x is negative 2, minus 35. Now, I'm going to combine all my polynomials together because I have now satisfied my multiplication and my division. And all that's left is my addition subtraction. So let me rewrite the equation as 4x squared plus 8x plus 15 plus x squared minus x minus 27. minus, we're minusing this, so that's going to be subtracting the whole parentheses x squared minus 2x minus 35, which, one last thing, when we're subtracting by an entire polynomial, we need to distribute that negative. So I'm going to quickly rewrite this as 4x squared plus 8x plus 15 plus x squared minus x minus 27 minus x squared minus x squared plus 2x plus 35. Again, because we're distributing the negative to the inside since we're subtracting by the whole polynomial. I'm going to ask that you try and simplify this one on your own. And let me know what you get. Okay, hopefully we got that answer right. And if we did, then that brings us to the end of our tutorial. So at the end, it goes over our summary, which gives you different method of multiplying polynomials. However, you guys know the try and true method, but if any of these speak to you, none of these are wrong, just they're not universal. Maybe this one's close to being universal, but it's basically what we do anyways. That being said, I hope this helped, and good luck on your math journey.